is Myriam Vanneste. I'm R&D manager at Centexbel in the research group of coating and finishing technologies. And through various technologies and chemistry, we try to add value to textiles, plastics, paper, and so on. The focus is on making formulations that we then use in coating, printing, finishing technologies, dyeing technologies. And the main focus is to have more durability, more sustainable materials in the end.
My name is Olivier, I am R&D manager in Centexbel in the group of sustainable technical textiles and composites. The aim of our group is try to find new product and also a new way to recycle plastic and textiles. And that's in different fields such as the composites, but also in the medical field.
My name is Isabel Schrijver. I'm working at Centexbel as R&D manager for the group Melt Processing Technologies. We start with polymeric materials. First of all, do full characterization of the polymers as such, and then go over the processing both in textile applications or in plastic applications up till the end of life of the materials. We are focusing on sustainable applications, durable materials, and high performance applications. If I look back in time, what we have been doing, it was performance of materials. Trying to have stronger fibers, trying to add some additives to tune the properties. If I look now, I think main focus for us and a lot of our companies is that there's an additional layer and that we are looking sustainable materials and of life. How can we tune this additionally, not only looking at performance of materials?
Yeah, the same for our research group. Though we see an increasing emphasis on sustainability in all its aspects, which means that we also look into bio-based materials, not just the polymers but also additives. And then the second topic is recyclability, which is difficult for us, quite a challenge, as we work with multi-layered materials, but also there we have the possibility to give some results and guidelines for companies.
Yeah, we have also the same problem about bio-based product and also recyclability, and the same for the composites. These composites are more and more complex with different kind of fibers, different kind of polymers in the same structure, but also in the medical field that we now see appear this problem of the bio-based problem, the recyclability, because now we would like to have all recyclable, and in the medical field is very difficult because there is a lot of different kinds of infection, and usually the structure are infected, and it is very difficult. And also I've seen a change in the regulation that will increase also the difficulty for us to the recyclability.
Yeah, not only recyclability, I think, because change in legislation also causes that we had to change some materials, looking at some additives that were added in the past, which are now forbidden, but our textile industry, for instance, has been used them for years. So we need to look for alternative materials. So it's even going broader than that, but I think REACH legislation, other legislations are also pushing us towards new applications, new materials, finding solutions for our industry.
In our group, the success that we have had, but I have two examples. The first one, it's in the medical field that we have created a new scaffold for tissue engineering and more precisely for new bones growth. And this scaffold was used in preclinical studies and demonstrate very good response. It will be for the future, will perhaps be a new medical device to help a person with bone defect. The second one, it's the creation of a new machine named Clean Mattress Simulator. This machine will mimic the cleaning of a mattress to analyze the resistance of the mattress to the cleaning. Because at this moment there is no study about that, and we are now in discussion to try to introduce this machine in the new standard.
Yes, from our side, one of our successes was also related to mattresses, where we developed a bio-based flame retardant here at Centexbel, and we were able to implement it as a coating for mattress sticking. The result was quite good, as it had the same performance as conventional frame retardants. It was bio-based, and let's say the main success was that we were able to use it in an industrial setting, because there you always have the challenge going from lab to industrial. And then, of course, another one of our successes is everything which is based with bio-based, which has to do with bio-based materials, so the bio-based coating for leather imitations, for instance, or the prints, the inks that we developed, always bio-based, so where we took some patents onto it and where we have different applications for bio-based materials.
If you're talking about bio-based colorants, I also have here some examples of bio-based fibers where we include, instead of using a coating or a dye afterwards, that we try to include this into fiber. Because for us it's important not only to have the polymer bio-based, but also to have all additives as well bio-based in the yarn. So we incorporated into yarn extrusion. And important for us was to look for an alternative for polyester. If you look at our clothing industry, 70%, around 70% is polyester based. So we looked at a bio-based alternative. So we started from a bio-based polymeric material, we tried to extrude it into fiber, and then we finally realized also some real clothing with it, 100% bio-based, with the advantage that it has the softness as what we used to have with our polyester material. So I think that's a very nice example, and that got moved forward our clothing industry as well to go to bio-based. And then the second example, staying in the field maybe of bio-based, is we also developed some self-reinforced composite materials. With here also the advantage that you have your reinforcing fiber and your, let's say, matrix are the same polymeric material, and end of life you can recycle the materials. So that would also be an advantage end of life when we evaluate the recyclability of the materials.
In Centexbel we have a lot of different kinds of projects, but the majority of these projects are applied projects very close to the industry. These projects are usually made with a consortium with different kinds of partners. Centexbel, of course, as research centers, but also industrial persons and university or high school.
Next to that, I think it's also important to work one-to-one with companies together, because sometimes we have companies that really come to us with a very specific problem, and there we do help them in a more private consortium, that we give them guidance, consultancy, that we use our labs to support them to find a solution for their problems. So they are very applied, of course, because after this kind of private projects, you do want to see that the company is really implementing it into their industry and putting it really into production.
Yes, and we often see that for small and medium-sized companies, it's quite difficult to find a way how to start with it if they've never done it. So I think they can indeed come to us, because we can support them in all the making the idea, have a look what's possible, what kind of funding is feasible, and then of course during the execution or even the reporting we can support. And then we still have our pilots, of course, which is important for us to do our research, but also companies can use them. So in the group of coating and finishing technologies, we start from small lab scale coating possibilities, printing possibilities, spraying, plasma equipment for improving adhesion, for instance, look into other possibilities for curing, like UV curing or infrared drying, looking into yarn coating. So there's a whole lot of machinery available for our own research and the companies.
I think that's important. We also call it our open innovation platform, being accessible also for our industry. So what do we have with, let's say, the plastic processing? We also start at lab scale with a few grams of polymers. We can do first evaluation of materials, but then we go up to pilot scale, so that we try to simulate the industrial processes. And then I think not only textile yarn extrusion, but we also have injection molding machine, we have oil extrusion, we have huge compounders working with kilograms an hour, just to simulate the processes as much as possible towards the industry. And I think also important that we keep on investing in those technologies, because, for example, we are this year investing in a recycling line, a thermoplastic recycling line, also to show to the industry that you can work with recycled plastics at the end.
In our group, in sustainable technical fibers and composite, we have also had a lot of investment. Investment was done majorly about the textile platform. In this platform, we have huge machines such as wrap and wrap, knitting machine, broderie machine, weaving machine, and all this machine has industrial capacity. But we have also a huge laboratory about microbiology testing, and also about the recircularity and disassembly of a different kind of structure, such as star for example.